All right. So this is the other problem, the method of sections problem, and it may look a little messy. I'm sorry, uh, but it shows something that we haven't seen before, which is that your sections don't have to be vertical lines. They don't have to be horizontal lines alone. They could be any kind of section you want. In this case, I chose one slanted, all right, to capture the members I'm interested in, which is the EI here and IJ. Okay, again, it's based on uh, actual theory here. So because we know internal forces exist in these members, we can apply this, and it doesn't matter how I cut it. Just cut it in a way that simplify your problems. Okay, so really what I'm looking for then is studying this problem here. Or I could study this larger problem. If you look at the knowns, I have AY, AX, GY outside, and then that's three unknowns which I can use to determine the reactions if necessary. On the inside, I have three additional unknowns. So each section will have four unknowns. So clearly, I do need to determine this reaction. So let's just do that real quick. For the full truss, in the x direction means that AX is 0 because there's no force in the x direction. In the y direction means that AY plus GY equals 17,000. Okay. Do a moment about A. Is 0 due to that. 4,000 times 9, which is 36,000. And that's negative because it's clockwise. 8,000 times 18. 8,000 times 18 is what? 144,000. Did I get it right? 144,000 also. Also negative because it's clockwise. 5,000 times 1, 2, 3, 4, 5. That's 25,000 clockwise. Sorry, 9 times 5. 9 times 5 is 45 times 5,000. That's what I'm looking for. So that's 255,000. 45 times 5 is 225,000. Also clockwise. And I'm choosing GY up, so that's anti-clockwise plus, wow, GY times 5, 6, 54. 54 GY equals 0. Okay, which means that GY is 144 plus 36 is 180. 180 plus 225 is 405,000. Divided by 54. This is divisible by 9. My goodness. Calculator help. A little too late for me. 405,123 divided by 54. 7,500. Okay, so G is 7,500. So I can solve for A, which would then be 9,500. Okay. Okay. So with that determined, I can go zoom right into my section. And that looks like this. F, E, I, F, F. Got 3 forces here and 1 force here of 7,500. And like before, first thing you want to do is find out how to simplify this problem. What choices, what force balances and moment balances will simplify the problem. If I did a moment about this, I eliminate 2 unknowns, so that's a natural choice right there. Moment about point I gives me about point I is clockwise, so FEI times it's FEF, not FEI. FEF times, what's that distance? FEF times 12. About this point, that's 7,500. Also clockwise. Times, that distance is 18. Equals 0. I think I got all the forces. This and this about this. Okay, so that gives me FEF easily. It's actually negative. Negative that 9, sorry, 6, 4, 2, calculator help. 7,500 times 18 divided by 1250, and that's FEF 1250. Unfortunately, the question is asking only for FEI and FIJ, so that was not necessary, but we have that number now. We'll go on. I wasn't thinking. Okay, to get FEI, naturally I would want to do a Y balance because this is in X, this is in X, and I have 2 things in Y. So that's an easy choice right there. Also in Y, I get FEI. All right. 2 and 2. Oh, there's a 5,000 there. Snap. So this moment balance is wrong also. Okay, we don't need FEF anyway, so I'm just going to take that off. Start all over again. Y balance. There's a 5,000, so FEI plus 7,500 minus 5,000 equals 0, which means FEI equals negative 2,500. Negative 2,500. Okay, so we have FEI. We need to get FIJ. All our need is find the moment with this, or I could do a force, but well, let's just do a moment and get rid of this here. Moment of this about E or about F shouldn't make a difference. Actually, about F complicates things because then I have a moment in this direction for FEI. I have a moment in this direction. It doesn't make a difference. Okay, doesn't make a difference what you choose. Actually, I probably want to use E because E crosses here, eliminates FEI, eliminates FEF. So all I need is FIJ about E. This about E, this about E. Let's do a moment about E. And that gives me Fij is clockwise, so negative Fij times that distance is 12. This is 0 because it goes through E. 0 because it goes through E. This is 5,000 times 9. And it's clockwise also. Plus 4,500. 5,000. Anti-clockwise 7,500 times 18. And this is negative, sorry. Because it's clockwise. So positive 7,500 times 18 equals 0. Gives me Fij equals, calculator help again. 7,500 times 18 minus 4,500 and divided by 12. Let's there. I lost the number. 7,500 times 18. Oh, that's 4,500. Where's that? Do that again. 100 times 18. I'm just going to use the solution. The solution to that is 7,500 pounds. And this is in pounds. Okay, so because this is negative, it's actually compression. Because it's positive, it's actually tension. Just like we had talked about before. So this is the method of sections. In some cases, you actually combine both method of sections and method of joints. For instance, for this kind of section, if I wanted to find out the force in member DE, right? I already know this force. I already know this force from the method of sections. I know EF and EI. So all I need is this section, this member, and this member. So I can apply method of joints at joint E to get those two unknowns. In a situation like that, you're combining two methods. You could have just said, slice through this instead of applying this and determining. But for instance, if I had you to determine this member, this member, this member, this member, this member, there's no one section that works. You have to combine methods. Anyway, the point is that this simplifies your problem. Method of sections is usually a few lines compared to method of joints. When you're looking inside a large structure, that is. And there are times when it's actually more convenient to do method of joints, when you have simpler truss systems. Hope this makes sense. Look through more examples, work your homework problems, and ask me questions during office hours if you have any. Thank you. Have a good day.